S Technology for robotics workshop. S.S. Technology is in Chennai, India. Okay, today we have workshop on robotics. Okay, so if you say robotics, robotics is the engineering science. Engineering science and technology. Okay, and the design, manufacture, application and structural disposition. Robotics is related to electronics, mechanics and software. Next. Today we have workshops on robotics at S.S. Technology, Chennai, India. Domain of robot operation. One is microgravity, aerial, underwater, ground, stationary. Next. Degree of autonomy. See, if you say robot, quality of being self-controlled, amount of human control required for human's operation, can operate without human intervention. Robots are categorized by the goals they are designed to achieve: personal entertainment, manufacturing and entertainment. See, classification of robot. One is in medical, you have surgical robot, robots on earth, robotics in space. Next, robots on earth. If you say robots on earth, in the cylindrical robot is there, square robot is there, casted robots are there, spherical robots are there. Next, robot in space. If you take robots in space, three specific mission areas. One is exploration robotics, science payload maintenance, on orbit servicing. Two space robots are remotely operated vehicle, ROV. See, this ROV is very important role in water and space also. Remote manipulator systems, RMS. Next. This is a firefighting robot. This robot is designed by our students. Okay, this robot will first detect the fire. Once the fire is detected through sensor, then the robot move to near the fire and pump the water. Next. Robotics. If we say robot, different sections are there. So, parts of a robot is number 1, microcontroller section. Number 2, sensor. Number 3, mechanical parts. Next. So, if we take microcontroller section, in our robot, see, we are using PIC system 8 sensor microcontroller and L293 motor driver and DC motors and water pump motor, and we are using power supply plus 5 volt and plus 12 volt, fire sensors. Next, the block diagram of our robot. See, we are using fire sensor. That is the first section. From the fire sensor, the signal comes to PIC microcontroller. This is the microcontroller section. Then the microcontroller give output to L293 motor driver IC. Here, two motors connected. Next. See, this is the fire sensor details. So, IR receiver and transmitters are there. So, that IR receiver work based on the light intensity. So, if fire comes, the IR sensor will give the voltage. That voltage comes to your microcontroller. Once the voltage is detected by the microcontroller, then the microcontroller will send the data to your robot. That is to your motor driver IC. Then the robot will move to the fire. Next. This is the pinout diagram of PIC system of 8 sensor near microcontroller. Next, the feature of this PIC microcontroller is it is a 8-bit microcontroller, then RISC CPU, that is reduced instruction set computer. Then compatible is 20 to 40 pin IC. Then operating speed of this microcontroller is 20 MHz. Then the memory is flash power memory of 8K, RAM is 368 bytes, data EEPROM is 256 bytes. Next, feature of this PIC system 8 sensor microcontroller is 5 I/O ports, 3 timers, analog to digital converter, multiplexer and parallel serial communication and capture, compare and pulse width modulation. Everything is built in this chip. Next. So this is a motor driver IC. In our robot we are using L293 IC. In this IC you have 4 drivers. So this is driver 1, driver 2, driver 3, driver 4. 2 drivers are connected to one motor. So if you send the digital signal input of the driver, then this driver will give output as motor voltage. So that voltage goes to motor. Then according to the output of motor driver IC, the motor will rotate clockwise or anti-clockwise. Next. Say this is function of firefighting robot. So from if fire is detected, according to the light intensity of fire, this fire sensor will give the output. That output goes to input of your microcontroller. Then the microcontroller will move the robot and pump the water. Next. Now we are coming for the practical section. Say for constructing a robot, we need tools. So for constructing a robot, we need tools. One is screwdriver. So these type of screwdrivers are needed. Okay. The next is cleaning of brush. Then next is you need a multimeter to measure the voltage, DC and AC voltage. Then you want to solder, so we need a soldering iron and some wires. This is the wires. Then you need a lead. So soldering, for soldering we need the lead. Okay, this is the tools to construct needed to construct a robot. And then what are the hardware requirements of robot? You need a microcontroller PCB. This is the microcontroller PCB. This is the component side. This is the solder side. Then next you need two wheels. This is the robot wheels. So in our robot we are using two motors. For that two wheels is needed. Then this is the DC power supply. 12 volt 1.3 Ah DC battery. It's a rechargeable battery. Then next is the robot base. This is a robot. Here you are fixing two motors. Okay, and here we are fixing the microcontroller board. Okay, this is the top of the robot and this is the bottom of your robot. Now we are going to solder this PCB. So here, see, for inserting PIC microcontroller, we need a 40 pin base. So you insert this 40 pin base in this PCB. Like that you have to insert carefully. That is very important. Once you insert this side, change another side and insert the PCB. See here, this is not go properly. So take the small screwdriver and insert it. Now, see, this is your base is inserted. Once it is inserted, your base is inserted. This is the soldering side. So take your lead, solder your IC base. So take the lead. This is the iron. So take the lead and keep the soldering iron on the PCB and pin and insert the lead. So the lead slowly gets soldered. See here, like this end you solder it. Okay, then you solder the next pin. So like this, one by one, you solder each IC base. Properly you have to solder. So this pin should not get shorted. So once you solder like this, you solder other components also. So once you solder, once you solder this IC base, take the next component, crystal oscillator, diode and everything. You take the next component, take the next component, everything. Okay. So this is complete soldered PCB. Okay, in this PCB, see here, this is a 40 pin IC base for microcontroller and this is the L293 IC base. Then this is the 7905 5 volt regulator. Then this is the filter capacitor. This is the AC DC to converter. Then this is the crystal oscillator. Then this is the power on reset resistance. Okay, this is the complete component side microcontroller board. This is the solder side. You have to solder properly. Once you solder, now your microcontroller board is ready. Now take your microcontroller, that is microcontroller, and insert the microcontroller in this PCB. Take the microcontroller PIC S.S.TECHNOLOGIES F877A IC and insert this PCB. Like that you take L293, insert the PCB. Now coming to the mechanical section of your robot, take your robot base first. This is a 2 DC motor. This is a 2 DC motor. So here positive and negative is there. Here also positive negative is there. Remove the net, and in this base, robot base, this is the back side, this is the front side. So take the back side and insert that motor, DC motor, fix the net properly, tight it. And then take another DC motor, insert it. So your DC motors are fixed. two motors are fixed. This motor is tow load 300 milliamps current. Then take the another wheel. Fix the wheel properly. Here in this wheel, the screws is there. Tight the screws. So the wheel is fixed. Take the another wheel. This is another wheel. Fix in another end. Say here in this motor you have holes. So insert these holes. Okay, and then fix the screw. So your robot wheel is fixed. This is the motor, wheel is fixed. Now next, take your microcontroller board. Fix the microcontroller board. Take one screw. Fix the microcontroller board. Then next is, after fixing the microcontroller board, take the DC battery. Okay, here this is the positive and this is the negative. Okay, you have to connect carefully. First you have to fix the battery properly through this tape. So fix the battery, because while running, no, the battery should not come out. So tape it, this battery. Instead of using screws, use the tape. So once your battery, you have fixed the battery through this tape. Then connect this positive and negative to your microcontroller board. So from this DC power supply, this is the 12 volt 1.3 Ah battery rechargeable. So from the battery, 12 volt comes over here. So here you have a 5 volt regulator. This 5 volt convert 12 volt into 5 volt, that is it regulate, and then it gives power supply to your microcontroller and L293. Now the assembling of robot is over. Okay, assembling of robot is over. We will take this robot, complete robot. Take this complete robot. Once its assembling is over, the robot is like this. See, if you take the bottom of the robot here, from the positive negative is connected to this microcontroller board. Each motor is connected. So if you see this, from this motor, you will get, from the DC motor, you will get positive negative, it is connected to L293D. So this is the power supply wires. So connect positive to positive, negative to negative to this DC motor. Now we will test this robot in a robot room. Come to the robot room. Please come to the robot room. Now the robot is completely assembled. Now we will connect this battery to the robot. So the robot will start to work. For functioning, you have to program. So you have to program the microcontroller using embedded C. That code, X code, is to be loaded in the flash program memory. This is your complete robot. This is another type of robot. This is called universal robot. So this robot will control from the PC. This is a firefighting robot. Next, this is the RF based robot. So remotely you can control. Thank you. Welcome to S.S.TECHNOLOGIES.